In this video, I'm going to be demonstrating the process of producing this 5-inch tall segment wood egg, which contains more than 4,500 individual wood segments. The segmented wood egg is comprised of 47 segmented disc layers, and each disc layer contains 96 wood segments per layer. The process begins by cutting segments of 48 segments per disc, and then inserting 50,000-inch thick maple spacers between each of the padauk pieces of wood. And we end up with a disc that looks at a cross-sectional area much like this. We have alternating padauk and maple. So there's 48 padauk pieces in here and 48 maple spacers, giving us our total of 96 segments per disc. This is glued up in a thick disc and then sliced off to give us these thin discs, which are then rotated a half a segment per disc, glued back together to produce our final block that's needed to turn this segmented wood egg. In this video, I'm going to demonstrate the complete process of producing the segmented wood egg. We've also produced 3 other videos in which we describe additional details on producing other styles of segmented wood eggs. Like in many of my projects, I begin by designing the segmented egg using the Woodturner Pro software. This gives me some idea as to the final design and provides me with the width of the segments that I will need to cut to produce the 48 segments per disc. Each layer will contain 48 padauk segments, plus the 48 maple spacers, and each disc will be 0.1 inch thick. I will need a total of 47 of these disc layers for this project. In addition, the top and bottom disc will be made from Catalog's wood, with 12 segments per disc with no maple spacers. From the software, I determined my padauk spacers will need to be 0.26 inches wide, minus the 50,000th inch thick maple spacer. Therefore, I'll cut my padauk segments to an outside width of 0.21 inches to produce a segmented disc with 48 padauk spacers, into which I will insert the 50,000 inch thick maple spacers to produce the desired 96 segments per disc. As in our previous video on making these eggs, I will cut all the segmented discs with an outside diameter of 4 inches and an inside diameter of 1.25 inches to enable me to stack and rotate all the discs on a manual during the glue-up process. I set up the Accu-Wedge system to cut 48 segments per disc. I adjusted the outside width of the padauk segments to be 0.21 inches. Each of my disc blocks is 1.5 inches high, so I need a total of 5 of these disc blocks to provide for the 47 discs that will be cut from these disc blocks. I assembled 48 of the padauk wood segments and inserted 48 maple spacers, each 50,000 inch thick, between each of the padauk segments to produce my desired pattern. I'm using epoxy for the glue up of these segments due to the long setup time enabled by the epoxy. I coat both sides of each of the segments and spacers and assemble them into the desired pattern. Yes, epoxy is messy, and that is why I'm using gloves and a disposable smock for this operation. After all the pieces have been coated with the epoxy glue, I use rubber bands to clamp the assembly. I prefer rubber bands rather than the hose clamps used by others. The rubber bands provide for a more uniform clamping pressure around the entire circumference of the glued up segmented disc. I wipe off the excess epoxy glue that has seeped out of the joints. Finally, I use a dowel to clean up the inside of the assembly and to make sure that all of the maple spacers are properly aligned and none of the spacers overhang inside of the disc assembly. I use as many rubber bands as necessary to thoroughly clamp the assembly and provide for tight joints between all of the wood pieces. I allow the epoxy glued assemblies to dry and harden overnight. The rubber bands are glued to the assembly and can most easily be removed by just cutting them off. I use a knife to cut the rubber bands and then peel off the rubber bands as much as possible. The excess glue and residue from the rubber bands can most easily be cleaned up on a wire wheel on a bench grinder or buffing system. I just removed the major excess glue so that it will not clog up my sanding disc in the next step. Finally, I clean up the disc assemblies on my edge sander. I sand both the faces and the circumference around the disc assembly. I sand the circumference sides so they can easily see the patterns of the segments when the sliced discs are realigned and glued back together in a future step. I sand the faces of the disc assembly so I have a good adhesion surface for the double-sided tape in the next step. Be careful to keep the disc assembly round and not sand too much off any one segment around the circumference of the disc. I apply double-sided tape to the segmented disc assemblies and then attach them to the carriage on the Accu-Slice system. To speed up the operation, I mount 2 or 3 discs onto the carriage at the same time. I mark a line in each of the discs with a pencil or marker. This line is later used to realign each of the thin segmented discs during the glue-up process. I lightly clamp each of the disc assemblies to the carriage for a few seconds to thoroughly set the double-sided tape in order to properly hold the disc to the sacrificial fence of the Accu-Slice carriage. I move the Accu-Slice carriage to line the mounted discs so that they just touch the bandsaw blade, and then I lock the Accu-Slice table in place using the 2 coarse adjusting screws. The segmented discs are moved back away from the bandsaw blade, and the index wheels advance 1 full revolution to allow for the bandsaw blade curve. The index wheels advance 1 full additional turn to provide for the first cut, and the mag jigs are locked in place. The purpose of this first cut is to true up the surfaces of the disc so that all future cuts will be perfectly parallel to the surface. After this first cut, the mag jig clamps are released and the discs are moved back to the starting point. The index wheels advance 1 full turn to allow for the bandsaw blade curve, and then advance 2 more full turns, or 0.100 inches, to provide for desired disc thickness as required for this project. The mag jigs are activated and the disc slices are cut. This slicing of the disc is continued until all the required segment discs have been cut. Before the sliced disc can be glued together, the fuzzies and burrs must be removed from the disc. A quick sanding of the flat disc surfaces and the disc edges with 220 grit sandpaper is all is required for this cleanup. After the discs have been cleaned up, I mount them on a wood dowel so that I can be sure they will mount on the wood glue-up jig, and also to plan for the final glue-up of the assembly. I have a total of 40 rings that I'll be gluing up here. And I put them on a dowel here to keep them straight. And I'll be gluing these up 10 at a time. This is a set of 10 I completed already. And I'm not using epoxy for these layers. I'm using Titebond 2 glue. And the reason for that is the epoxy just slips and slides too much. The Titebond 2 will set up a little bit quicker. It's just much easier to set them and get them so they don't move and go a lot quicker. So I have a jig here I made. It's consisting of a dowel into a block to keep it nice and straight. A little bit of tape here to get the exact size, and it's the exact diameter of my inner ring. So I glue up one at a time, alternating each layer a half a segment. And once again, I'm using my lines that I set up when I cut the disc. Since these discs contain 96 pieces of wood per ring, very minor fluctuations in spacing are observable. So that's one of the reasons I'm using the Titebond 2 glue, because it does move ever so slightly, even with the Titebond glue, and you got to keep adjusting it as you go along. Okay, that's the first 2 rings. I'll let that set about 10 minutes, and then I'll put on the next ring and just keep repeating the process until I have 10 rings glued up. 10 layers glued up, so I'll put this in my press for about 2 hours. As part of my gluing jig, I made a plastic disc which went on the bottom. This made it much easier to remove the glued up assembly because the glue didn't stick to the plastic piece. It would have stuck to the wood, made it much more difficult to get off. I clamped a set of 10 glued segmented discs in my press between 2 larger wood blocks to make sure that all the discs are glued with no gaps between any of the layers. I allowed the glued assembly to dry for at least 2 hours. This is the finished glued up assembly ready to go in the lathe, and I have 47 layers here of alternating Paducah maple, 96 pieces of wood per layer. And then at the top and bottom I have 2 3/8 inch segments of just catalogs, and these contain 12 segments per layer. So my total count on segments here is over 4,500 pieces of wood. I also then added a piece of round stock on the bottom and top, which will later be cut off on the lathe, and I just used these so that I can center it on the lathe. And what I did is I put this on a table and I just rotated it to locate my centers on both ends, and then I put center points on this, put it in the lathe, turned it, and then turned this down that it fits my chuck, so I can put this in my chuck on my lathe. It'll be centered based on the OD of this main body of the future egg. And so this is ready to go in the lathe now, and we'll turn this down to our finished egg. Okay, ready to mount this in the lathe. And I put my chuck on, so I'll mount this in my chuck. And I'll bring my tailstock up also. So I'm holding on both sides, at least for the initial turning. From my pattern, I've also marked my high spot. And so I'll be turning down. That'll be my high spot here. I'll be turning down on both sides of that to finish up the egg. At this point I sand the egg, starting at usually between 150 and 180 grit paper and go all the way down to 400 grit. Okay, I'm ready to reverse this. I'm going to take this chuck and take it off the lathe and put it on my rotating tailstock. And then I use a vacuum chuck to hold the egg while I turn off the opposite side. So I remove the chuck from the headstock, and let me first install my vacuum chuck. And then install this chuck in my rotating tailstock. Okay, that's done. So I just turn my vacuum off. And it should pop off in a few seconds. And there's our finished egg. This is the finished segmented wood egg, which is 5 inches tall. It consists of 47 layers of alternating padauk and maple wood. Each layer contains 96 segments of wood per layer, times 47 layers, and then the top and bottom layers are of padauk wood, each containing 12 segments per layer, which gives us a total of 4,536 segments of wood in this 5-inch tall wood egg. This is the finished egg after 3 coats of shellac and 2 coats of polyurethane. We have produced 3 other videos which describe the process of making segmented wood eggs in more detail. These videos are available on YouTube and also on our website.